Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand VRF configuration using static routing. But before starting the configuration, let me make you familiar with the topology. So in this topology, as you can see, I have three customer 1, customer 2 and customer 3. These are side 1 of customer 1. Let's say this is site 1 of customer 1 and this is site 2 of customer 1. This is site 1 of customer 2, this is site 2 of customer 2, this is site 1 of customer 3 and this is site 2 of customer 3. Okay, and all sides of customer are connected through router 1 and router 2. You can see all customers are using same network, same private network 10.1.1.0/24 in side 1 and 20.1.1.0/24 in side 2. Between router 1 and router 2, I am going to create sub interface, and you can see as here you are able to see, I will create three sub interface between router 1 and router 2. First Ethernet 0/0.10. I will encapsulate this interface for VLAN 10 and then I will assign IP address 12.1.1.1. On all interface I will assign same, on all virtual interface I will assign same IP address, and this interface will be the member of this VRF. Okay, let's say for customer A I will create VRF A. So this interface F0/0.10 and interface F1/0 will be the member of VRF A. Let's say I am creating VRF B for customer B. So F0/0.20 and this interface F2/0 will be the member of VRF B. And let's say I will create VRF C for customer 3. So this interface and F0/0.30 sub interface will be the member of VRF C. We will configure same SVI interface on router number 2 also, and we will define this for VRF A, this for VRF B and this for VRF C. And between customer A's and provider A's, this is actually my PE router and this is CE router. Between PE and CE also you can see I am using same network, so we will not have any problem, okay, because all interface are in different VRF. Okay, this interface will be in VRF A, this interface will be in VRF B, this interface will be in VRF C. So I can configure same IP address, right? And on sub interface also I will configure same IP address. This is IP configuration of router number 1. In the same way on router number 2 I will configure 12.1.1.2. okay, now guys, let's begin the configuration. First of all, I am going to configure IP address on customer router. So let me write down the note in notepad. Here I am going to write down the no command. And guys, to make reachability between side 1 and side 2 of customer, I will configure a static routing. Today we are not going to configure BGP. This is third video of VRF. So if you have not watched first video and second video, first you should watch those two videos. Okay. Now on router number 1, I am going to run command config t enable first, then config t, after that interface F0/0 no set and IP address. Let's say here I am using IP 1.1.2 255.255.255.0 exit interface F not F loopback 1 and IP address is 10.1.1.1 255.255.255.0 exit. I'm going to run this command on all routers. Okay, on my means router 3, router 4 and router 5. Let me copy the command and let me paste it on these routers. So let me take access of router 3 first. On router number 3 I'm going to say no, and till then let me take access of router 4 also. Say no, and router 5 I am arranging the console so that topology should be visible for you. Router 2, let me take access of router 1 also. Say note here, after that to router 2 Just give me 1 minute. Let me access all routers first. Router 2, router 6. No to this. Router 7. I am configuring IP address as well so that you can understand configuration from initial, from the beginning. Okay, because one people were have commented on my video, on VRF video, that please configure one topology from the beginning. Okay, so now I am going to paste these all command on router number 3 first. So let me paste the command. Okay, you can see the IP now. IP interface brief exclude unassigned. I'm going to configure same IP address on router 2, router 3, router 4 and router 5. So router 4 and then router 5. Okay, now let me configure IP on router 6, 7 and 8. So let me here change something, guys. On fast ethernet 0/0 IP address will be same 1.1.2, and on loopback interface 1 IP address will be 20.1.1.0. Let me copy it and let me paste this command on router number 6, 7 and 8. 6. Let me paste the command, same command on router number 7 also, and let me paste same command on router number 8 also. Done. IP configuration on customer routers is done. Now let me configure R1. So on R1 I will run command interface F1/0. First of all say no set and IP address 1.1.1.1 255.255.255.0. Exit interface F2/0 no set. Oh, but you know, if I will configure IP address first and then I will create VRF, then IP will remove. So first of all I am going to configure VRF. Okay, so enable config T and after that VRF IP VRF A, exit IP VRF B, exit, then IP VRF C and exit. Now I am going to define the interfaces in VRF. So let me start from here. Interface F1/0 no set IP address. Okay, first of all I will say IP VRF forwarding A. This interface is member of VRF A, and then I am going to define IP address 1.1.1.1 255.255.255.0. Exit. After that interface F2/0 IP VRF. Let me copy the command from here. This command IP VRF B and then say no set, then IP address will be 1.1.1.1 255.255.255.0. exit interface F3/0 and I am going to copy this command. Let me run this command on this interface also. VRF C and IP address 1.1.1.1 255.255.255.0 and exit. So this is the configuration of this interface, the physical interface which are connected to my customer router. Okay, now I am going to configure interface F0/0. First of all say no set here and then exit interface F0/0.10 encapsulation dot 1Q for VLAN 10, or I will configure this manually. First of all let me run this command on router 1. Let me take you to R1. and on R1 I am going to run this command. What happened? I think there is some misconfiguration. Config T, let me copy it and let me paste. Okay, so now here you can verify. So IP VRF first. So I have three VRF: VRF A, VRF B, and VRF C. In VRF A we have fast Ethernet 1/0. In VRF B we don't have any interface. In VRF C F3/0. So I am going to configure interface F2/0 and IP VRF forwarding B and IP address 1.1.1.1 Now you can verify again VRF. So let's see. Now VRF is fine. VRF configuration is fine. And so IP interface brief exclude unassign. You can see the IP configuration on all interface. So this interface is not shut down. This interface is also not shut down. So interface range F1/0 and F3/0. These two interfaces are not shut down. So let me say shut down. Okay. So now so IP interface brief. You can see the IP configuration. Okay. And so IP route, in the routing table I don't have, in global routing table I don't have any network, but so IP route VRF and A. So you can see in this VRF I have one prefix, in VRF B I have this prefix. Okay, in VRF C I have this prefix. Okay, now I am going to create some sub interface on this router. So interface F0/0.10 and encapsulation.1q for VLAN 10 and IP VRF A and IP address 12.1.1. Not IP VRF A, IP VRF forwarding A, forwarding IP VRF forwarding. What happened? I think interface F0/0.10 and IP VRF A. First of all I am going to remove this command from here. Okay, IP VRF forwarding A. Okay, and I think I have already assigned IP address on this. No, so let me assign IP address 12.1.1.1 255.255.255.0. exit interface F0/0.20 IP VRF forwarding B and encapsulation.1q for VLAN 20, and here I am going to say IP 12.1.1.1 again 12.1.1.1 255.255.255.0. done. Then interface F0/0.30 IP VRF forwarding C and encapsulation.1q for VLAN 30, and let me assign IP address 12.1.1.1 255.255.255.0. exit. Now if you will check VRF, so IP VRF, you can see in VRF A I have two interface, one is F1/0 and one is 0/0.10. in VRF B F2/0 and 0/0.20. in VRF C F3/0 and F0/0.30, and so IP route VRF A. You can see the routing table of VRF A. I have two network 1 and 12. Done. VRF B also I have two network. No, VRF B, not V. B. Okay, I have also two network here, and VRF C I have also two network here. Done. So now configuration of router 1 is done. Let me take you to R2. On R2 I am going to first create the VRF. So IP VRF A, exit. IP VRF B, exit, and IP VRF C, exit. I have created 3 number of VRF. Now I am going to assign interface in VRF. So interface F1/0 IP VRF forwarding A and IP address is 1.1.1.1 255.255.255.0. IP address is 1. Let me check what mistake I did here. Interface f1/0 IP VRF1 IP address 1.1.1.1 255.255.0. Okay, then interface f2/0 IP VRF B forwarding B and IP address 1.1.1.1 255.255.255.255. So it's saying bad subnet mask 255.255.255.0. Okay, then interface f3/0 IP VRF forwarding C and IP address is 1.1.1.1 255.255.255.0. Okay, so now if you will verify VRF, so IP VRF, you can see I have one interface in VRF A, I have one interface in VRF B, I have one interface in VRF C, and so IP route, I don't have any prefix in global routing table, but so IP route VRF A. You can see here also I don't have any prefix in VRF A. There should be one prefix VRF B, no VRF C. So I think so IP interface brief exclude unassign. So these interface are administratively down. Let me run no such command. Interface range f1/0, f2/0 and f3/0. I'm going to say no shutdown command on these all interface, and now you can verify the routing table of VRF. So IP route VRF C, you can see one network is there, VRF B one network is there, and VRF A one network is there. Okay, now let me create sub interface on router 2. Interface f0/0. First of all, I am going to say no shutdown to this interface, then interface f0/0.10 and IP VRF forwarding A and IP address 12.1.1.2 255.255.255.0. Okay, so what happened? Encapsulation protocol, encapsulation.1q for VLAN 10, and then let me assign the IP. Okay, then go to interface f0/0.20 IP VRF forwarding B and encapsulation.1q for VLAN 20 and IP address 12.1.1.2 255.255.255.0. Exit. Interface f0/0.30 IP VRF forwarding C. This is 20 B IP VRF B and IP address 12.1.1.2 255.255.255.0. Okay, encapsulation.1q for VLAN 20. I think I have defined it or not. Wait guys. Okay, this is dot 30 na. So encapsulation.1q for VLAN 30 and IP address is 12.1.1.2 255.255.255.0. So IP address is overlapping with this. I think both are in same VRF. So let me do one thing. No interface f0/0.20 and no interface f0/0.30. I have removed these two interface. Now again interface f0/0.20 IP VRF forwarding B and IP address 12.1.1.2 255.255.255.0. Okay, encapsulation.1q for VLAN 20 and say IP address this one. Okay, now interface f0/0.30 IP VRF forwarding C and encapsulation.1q for VLAN 30, and here IP address will be 12.1.1.2 255.255.255.0. Now if you will check, so IP VRF on router number 2, you can see VRF A have two interface, F1/0 and F0/0.10. VRF B have two interface, F2/0 and 0/0.20. VRF C have also two interface, F3/0 and 0/0.30. And so IP route in the global routing table, I don't have any prefix, but so IP route VRF A. So I have 1 and 2 help, VRF B, okay, and VRF C. Okay, now you can see I don't have any problem. Right now I am going to configure what? A static routing, because on router number 1, if you will check routing table of router 1, so IP route VRF A. So inside the VRF A routing table, I have only 1.1.1 and 12 network, right? So there is no 10.1.1.1 network and 20.1.1.0 network. For that, I will configure a static routing. So how I will configure a static routing, guys? See how I will configure a static routing on router number 1. Okay, it's confusing me, so let me change the host name of this router, say R1, and on router number 2 also I am going to change host name R2. Done. Now it's little bit better. On router number 1 I am going to say IP route, after that VRF, and then for which VRF you are configuring a static routing, for VRF A, and which network? 10.1.1.0. What is the subnet mask? 255.255.255.0, and then next hop IP address will be what? 1.1.1.1. That's it. Okay, so here I have invalid, no, 1.1.1.2. this is the next hop IP address, not 1. Okay, this is how we will configure IP routing for VRF1, and IP route VRF B network 10.1.1.0, subnet mask 255.255.255.0, and next hop IP address will be again what? 1.1.1.2. In the same way we will configure a static routing for VRF C also. So just I need to change the VRF name here, C. That's it. Okay, now if you will check routing table of VRF, so IP route VRF A, you can see I have directly connected network also and one static route, right? 10.1.1.0. let me ping. Am I able to ping 10.1.1.1 from here? Will it work? Ping will not work because router 3 don't have root. If I am pinging from here, so it will check the routing table. Soon we are going to discuss this also, that why from router number 1 I am not able to ping. Okay, if I will ping from here, what will be the source address? Source will be 1.1.1 and destination will be 10.1.1.1. It will check the routing table. Inside it will check which routing table? VRF1 routing table, right? But from here, actually when I am pinging, I am not defining any VRF. Soon we will discuss this. Before that, let me show you the routing table of other VRF. So IP VRF B. Okay, so here also I have this network, and so IP VRF C. Here also I have this network 10.1.1.0. Okay, now I need to configure which network? 20 network. So let me configure that also here. So IP route VRF A and 20.1.1.0, mask is 255.255.255.0, and next hop IP address is 12.1.1.2. in the same way I am going to configure a static routing for VRF B also, for same network, same next hop IP address, only I need to change VRF name. Let me do same thing for VRF C also, VRF C. And now if you will check VRF routing table, so IP route VRF and A, you can see I have 10.1.1.0 network also, and 20.1.1.0 network is also there with a static routing. So IP route VRF and a static. So you can see. Okay, in the same way for VRF B, so IP route VRF B a static. I have 10 network and 20 network inside the VRF B routing table, and VRF C routing table also you can see. Okay, now let me take you to R2, and on R2 I am going to configure a static routing. Okay, so go to config T, then IP route VRF. This is how we configure a static route in case of VRF. VRF, after that name of your VRF, then network 20.1.1.0, subnet mask 255.255.255.0, and next hop IP address 1.1.1.1.2, 1.1.1.2, which is running on router customer router. After that, same command for VRF-B and same command for VRF-C. Okay, then I need to define 10 network IP route VRF A and 10.1.1.0, 10.1.1.0, and then I can say here subnet mask 255.255.255.0, and next hop IP address will be 12.1.1.1. Okay, let me do same thing for other VRF also. Let's say VRF B and for VRF C. Okay, so now on router number 2 also you can check the VRF routing table. So IP route VRF A. I have 10 network also, or I can filter the output by using this keyword static. I have 10 as well as 20. Okay, VRF B 10 and 20 is there, and VRF C 10 and 20 is there. You can see the routing table of all VRF. Now R1 and R2 both have all prefixes. Okay, now let me take you to R3. On R3, so IP route. This router don't have 20.1.1.0 network. So again, I am going to configure one static route here. Okay, so say IP route. So here on customer router, we will not configure a static route. We will configure one default route towards R1. So IP route 0.0.0, 0.0.0, and we can say next hop IP address will be 1.1.1.1. I have configured one default route on R3. Let me configure this default route on other router as well. On R4, I have copied the command, and let me paste that command here. IP route 0.0.0, next hop IP address 1.1.1. Let me configure default route on R5. Enable config T IP route 0.0.0, 0.0.0, and next hop IP address 1.1.1. And in the same way on router number 6, router number 7, router number 8, I need to configure the default route. So let me configure here also the default route. Let me paste it. Okay, because here also next hop IP address will be 1.1.1. both side you can see I am using same IP address. Okay, now let me take you to R7. On R7 also I will configure one default route, IP route 0.0.0. okay, let me configure one default route on R8 as well. IP route 0.0.0, 0.0.0, next hop IP address 1.1.1. Now you can see the customer router have one default route towards router number 1, and router 1 have route for, you know, this prefix also for this customer network also. So IP route VRF A. So this router have route for 20 network as well as 10 network. This router have 10 network and 20 network in VRF B also and VRF C also. So now customers should communicate with each other, yes or no? So let me take you to R3, and from R3 I am going to ping 20.1.1.1, 20.1.1.1, and see ping will work or not. Ping should work, yes or no? Ping should work because R1 and R2 both have route. Why ping is not working? Because you are pinging 20.1.1.1 from the source, from the exit interface. So source will be 1.1.1.2. So here you have to say source is 10.1.1.1, and this time it will work. Repeat 1000. See, ping is working fine. All customer can communicate with each other. Yes, from router number 4 also. If you want to see, let me take you to R4. And on R4 ping 20.1.1.1 and source 10.1.1.1. See, repeat 1000, ping is working. And from router number 5 also ping 20.1.1.1 and source is 10.1.1.1, 10.1.1.1. see, ping is working, repeat 1100. see, okay. So this is how we configure VRF by using a static routing. How ping is working? See, when I am pinging 20.1.1.1 from router number 1, it will check their routing table. Inside their routing table there is no route available, so it will one default route is available, so it will forward traffic towards default route. R1 will receive the ICMP request on this interface, and this interface is a member of which VRF, VRFA. It will have one SAP table for separate VRF, for VRF1. If you want to see, you can check on router number 1. On router number 1, so IP SAF VRF A. You can see this router have knowledge that whenever I need to forward traffic to 20.1.1.0, next hop will be 12.1.1.2, and to reach to this next hop, exit interface will be fast Ethernet 10/0/10. Okay, so it will have SAP table for all VRF, VRFA, VRFB and VRFC, and this is how all customers are able to communicate with each other. Okay, or you can run command on router number 1, so IP SAF VRFA and 20.1.1.0. you can see the next hop IP address is 12.1.1.2 and exit interface is this one. This is how, guys, we configure VRF by using static routing. Now hope it's clear to you. I don't think that we have any more concept in VRF by using static routing. And one people were saying that how to check ARP table in case of VRF. So here if you will run command show IP ARP, you can see there is no any entry. So you will run command like show IP ARP VRF and then name of your VRF A. You can see the ARP table of VRF A. In the same way you can check ARP table of VRF B. You can check ARP table of VRF C. Okay. See the ARP table. Okay. So whenever router 3 will ping 20.1.1.1, router 3 will forward traffic to router 1, and router 1 have route, it have ARP table, and in ARP table you are able to see the MAC address of 12.1.1.2 is resolved here. This is the MAC address of 12.1.1.2. It will change the layer 2 information and it will forward to router 2. Router 2 will receive traffic on which interface? Fast Ethernet 0/0.10. And after that, this interface is member of which VRF on router number 2. F0/0.10 is a member of VRF 10. So it will check routing table of VRF 10. So IP route VRF A, and inside the routing table of VRFA, 20 network is there, and so IP SAF VRF B and 20.1.1.0. you can see the next hop is 1.1.2. exit interface is to fast Ethernet 2/0, so it will forward traffic from fast Ethernet 2/0. Okay, I have checked it in VRF B, so here it will be VRF A. VRF A. Next hop IP address is 12 fast Ethernet. Exit interface is fast Ethernet 1/0. Next hop is 1.1.2. It will forward traffic from fast Ethernet 1/0. When router 6 will receive, it have also one default route, so it can forward the reply message. When router 2 will receive the reply message, it will receive on fast Ethernet 1/0. Fast Ethernet 1/0 is member of which VRF? VRF. So IP VRF B, VRF A. Fast Ethernet 1/0 is member of VRF A, so it will check routing table of VRF A. So IP route VRF A. Inside the routing table, route is available for 10.1.1.0. It will check the SAP tables. So IP SAF VRF A. So IPsec VRF A, and so IPsec VRF A, you can see for 10.1.1.0, for 10.1.1.0. Next hop is 12.1.1.1, and exit interface is fast Ethernet 0/0.10. So it will forward traffic from this interface. In the same way, router 1 will process the traffic and it will forward towards router number 3. Okay, so now hope it is clear to you guys how to configure VRF by using a static routing. If yes, if you have learned something from this video, please hit on like button. If you have not subscribed this channel, please subscribe the channel. We will meet soon in next video. Till then, stay safe. Bye bye.